fiction, science fiction, horror, fantasy, crime, LGBT, thriller.
You have now entered the House of Mystery with your hosts, Eric Shapiro, David North Martino, John Copenhaver, and Al Warren.
Heard on KCAA 106.5 FM Los Angeles,
102.3 FM Riverside,
and 105.0 AM Palm Springs.
Now today we've got a great guest. We're going to get into astronomy more, a little bit space, aliens and all that, but we've got someone with that's a scholar. So joining us from the SETI Institute, of course, is Seth Shostak. Thanks for being here, Seth.
It's my pleasure, Al.
So, are there aliens?
No. Yeah, start saying, where do you begin? And you drop right in the middle of it.
Are we alone?
Well, we don't know. That's the actual answer, because there's no compelling proof of any life beyond Earth, not yet. But it would be remarkable if we were alone, because, that would be, I don't know what it'd be like. It would be like the inhabitants of some South Sea island 500 years ago sitting around thinking, well, there's a lot of water out there, but we don't see anybody else. So maybe we're the only society on Earth. Well, maybe they were, but they actually weren't. So given all the real estate out there in the cosmos, I think it's a very, very safe bet that we're not alone.
So how do we take all of these reports, like constantly hitting the news that, people see lights and flights and all sorts of weird things in the sky, and we've had a lot of people on that we've interviewed that have been probed and abducted, and then they can tell you all about the different varieties of aliens and stuff like that. Mm-hmm. Where do we go with that? Like, because we don't have any proof of any of that, do we?
Well, I don't think so. I've never heard or seen any, evidence that I thought, well, this is really compelling proof that we're being visited, even though something like 1/3 of the public thinks that's true. On the other hand, I think 11% of the public doesn't think we went to the moon and stuff like that. But in the case of visitation, I would think that if it were really happening, you would have some really objective evidence that would make this whole question be beyond, anybody's ability to refute it, that you could go down to your local science museum and see something that shows, well, here's the evidence for why we're being visited. There are thousands of satellites that photograph the Earth every day. Or you can go to Google Earth and see the results of some of those, but they're being done all the time. And many satellites actually show much more detail than the ones you can find on Google Earth, because, they're Defense Department satellites, or they're, run by the French or other Europeans for their own purposes. They never seem to show anything. You have, I estimate many 100,000 amateur astronomers looking at the sky whenever it's clear. They don't ever see anything. So the fact that you get reports from people that they've been abducted or probed, hard for me to imagine that the aliens would come all this way just to probe people, but who knows? It'd be hard to justify the expense, I think. But, it's not that it's impossible. It's just that there's just no good evidence. It's like saying, that, that the gods are wreaking havoc on Florida by churning up this hurricane. There are perfectly acceptable other explanations for these things. So I wait good proof. I haven't seen it.
Yeah.
Now, that brings up a question, though, Seth. As I'm sitting here listening, I'm tending to agree with you, although it's killing me inside, because I want to believe, in the words of Fox Mulder. But what are we looking for when you say evidence? What are we looking for? There could be so many different types of life out there. Are we looking for grays? Are we looking for mantis people? What are we looking for?
Well, when it comes to science, when you talk about the research community, what are they doing to look for life beyond Earth? They're doing several things. The big effort is in finding some life here in the solar system. So, that would be Mars, or maybe there are 3 moons of Jupiter that have big oceans, we think, and so there might be some life in there. There are a couple of moons of Saturn that look appealing, in particular Enceladus. Again, it's a moon it's covered with ice, but there's clearly a liquid ocean underneath it. Okay, those are all places we can reach with our rockets, and that's where, if you will, the big effort is for finding life beyond Earth, because we can get to these places, and the kind of life you would find would be microbial. You'd need a microscope to see it, okay, like bacteria, that kind of thing. And that's undoubtedly the most prevalent kind of life in the universe, assuming there's life. Because, think of Earth. For the first 80% of its existence, the life was all microscopic, okay? So that's where the big effort is. That's what NASA does. The Europeans do it. Japan and China are getting involved, India. So that's the big effort, to find life in space. And you may say, well, yeah, but those aren't the Greys or anybody like that. No, that's true. It's not. But it is life. It's biology. In terms of finding, if you will, sophisticated life like your next door neighbors, assuming they're at all sophisticated. I mean, that's the province of SETI experiments. That's what we do, where you're trying to pick up a signal that would indicate that somebody's clever enough to build a radio transmitter. And you're not going to find those guys in the solar system. You have to look at deep space. You have to look in the directions of other star systems. But there are plenty of other star systems. There are a couple of 100 billion star systems in our galaxy. And so that's the kind of effort being made there. It's very, very much smaller than looking for life on Mars, for example.
So are you thinking that if you did get a signal from alien beings, it would come in the form of a radio wave?
Well, that's the kind of experiment that we have been doing for a while. That's kind of the classic SETI experiment, looking for radio waves. That makes sense. Radio waves travel at the speed of light. They're pretty easy to produce, and, they're very inexpensive. You might say, well, who cares about expense? But, even the aliens probably care about expense. When I say inexpensive, it doesn't take a lot of energy to send bits of information from one star system to another. And the other thing is that the radio waves go right through the gas and dust between the stars, which is a somewhat of an advantage. But there are other experiments like looking for, laser flashes and things like that. So light, if you will. But it's all what we call electromagnetic radiation. We're looking for either light pulses, lights in the sky, or radio transmissions. That's what we generally do.
So you guys are transmitting out to space right now?
No, we don't transmit at all. We leave that to your. We leave that to this show, for example. You guys are transmitting. Now, the difficulty with that, there's some people who think it's dangerous. I don't think it's the least bit dangerous. But in any case, aside from that argument, the real problem with transmitting is you've got to really do it for a long period of time. You can't just transmit a quick message for an hour and say, well, we've pinged the aliens. Let's see what they have to say. I mean, what are the chances that they're looking at Earth at that time, at the right frequency and whatever, and the right sensitivity? But, there are plenty of signals going off into space willy-nilly, right? Like the radars down at SeaTac Airport. Those signals go into space, so they're doing the real transmitting. But as I say, the principal problem is, suppose you do transmit into space and the nearest aliens are, 200 light years away, which, by the way, would be pretty close. It'd take 200 years for the signal to get there, another 200 years for the response, assuming there is a response, to get back to us. So 400 years have gone by and you've lost all interest in the project. So, that's not a very interesting experiment to do.
Wow. Go ahead.
How fast does a radio signal travel?
Speed of light.
Is it really that fast?
Light and radio are the same thing. That's, just freshman physics, but it's just all electromagnetic radiation.
Now, does it slow down over distance?
No, not that we know about. That would be new physics, but no, doesn't seem to. It just, that was Einstein.
So
the speed of light is the speed of light.
So, like you suggested, in 200 years, let's say that they have faster than light travel, but we could be sending a signal out today that will be responded to in 200 years. So, how do you think our culture will have changed? I mean, would we be more accepting, or, would we still see this as some type of an invasion? I mean, I'm sorry, Seth, my mind is just awash with ideas right now.
Yeah. Well, you're asking about sociology, actually, not so much about the experiment. Now, I said 200 light years just as an example. We don't know whether they're 200 light years away or 2,000 light years away or 20 light years away. We don't know any of that. But if you don't go out at least a couple of hundred light years distance, you don't actually encounter very many stars. The farther you go out, the more stars you will have passed. So, if you really want to broadcast with some hope that somebody hears it, you have to, the signal has to go quite a distance. But, yeah, I mean, that's a very long-term thing. I think it's also relevant in terms of a question you guys were addressing at the beginning. Are we being visited? There's always the question in my mind is, well, why are they visiting now? Why didn't they just visit Archimedes or maybe Julius Caesar or something like that? And you can say, oh, well, no, they wouldn't have known because they wouldn't have been able to pick up any broadcasts from, Roman Empire radio or anything like that. They wouldn't know about Julius Caesar, and they wouldn't come to visit if they didn't know that there was something interesting here. But they don't know about us either because we've only been broadcasting really since the Second World War, high-frequency stuff. So, I think that means that it's pretty safe to assume that nobody here is coming because of any broadcast since the Second World War. They can't get here fast enough. So, that I think that bears on the whole UFO phenomenon. Why are they here now, just in time to probe you, right? I mean,
well, can you blame them?
If they're going to probe, if they wanted to probe, it better be me.
Well, start saying, look at my profile pic. Can you blame them? I mean,
yeah. Well, it's a little self-centered. Maybe it's right.
Yeah. What are the best places then that you would look for intelligent life? Like, is there certain parts of the galaxy or certain parts that you think would be the most likely?
Well, there are a lot of people have given a lot of thought to that. There are plenty of papers about, the galaxy has a habitable zone, which is to say there's some parts of the galaxy that really are better than others. And when they say better, what they really mean is not quite as bad. Some parts of the galaxy spawn new stars fairly frequently, new big stars, and they blow up fairly quickly. And when they do that, they might sterilize all the area around them. And, so some scientists have suggested that's not a great place for ET to hang out because he's going to get blasted pretty quickly. I don't know that any of that is terribly relevant, actually, because the galaxy is so large. But what we are doing now, where we're pointing our antennas, is in the direction of what are called red dwarf stars. These are little runty stars smaller than the sun, but there are lots and lots and lots of them. And that means that many of them are quite a bit closer than stars like the sun. So signals would be stronger. And they are known to have planets, and many of them are known to have planets in what's called the habitable zone, which means they're at the right distance from that star that if there are any oceans, the oceans won't freeze solid permanently or just boil away instantly. So, we try and second guess where biology might, kind of be spawned in the universe, and that's where we aim the antennas.
Well, again, Seth, we're assuming that we understand, biological life. I mean, maybe this is a species that has adapted or evolved to live in more harsh conditions or, less habitable conditions.
Well, always possible. But on the other hand, if you say, look, we want some sort of, biology. I mean, if you're talking about biology, right? What is biology? It's just organic chemistry, really. And it's, it's carbon-based here on Earth, which is to say that most of the big molecules have carbon in them. That's not a crazy idea, actually, and that may not be limited to the Earth. It turns out if you've taken high school chemistry, you know about the properties of carbon, and carbon is better than any other element in the periodic table for making big molecules. It's just, there's a whole hydrocarbons industry, Standard Oil, for example. I mean, so big molecules are better made with carbon than anything else. That's chemistry. And the chemistry on ET's planet is going to be the same as here. Chemistry is universal, just like physics is universal. So, you could say, all right, well, but maybe they don't have DNA, they have QNA or something. Well, maybe they do. I mean, you can't rule that out. That's certainly possible. But the real question is, if they develop intelligence, do they then also develop science? And if they do, then pretty soon they can build radio transmitters. At some point they can do that. And that's the only assumption. It isn't a matter of whether they look like crickets or, gray guys with big eyeballs and no hair or anything like that. It's just a matter of whether they have learned enough to be able to build a radio transmitter or a big laser or something else that would be useful to them. And if for nothing else, for communicating from one star system to another.
Now that's an awesome idea. Do you guys do you look for laser communication as well?
Well, we are building some equipment that will survey essentially the whole night sky every night, looking for flashes from big lasers. That makes sense. Big lasers might be useful for the Klingons, for example, to shoot a spacecraft from one place to another. That's one way you can get up to pretty high speed if you have a powerful enough laser, and you can just work it out. I mean, any laser that's able to shoot something of any size, maybe the size of this desk I'm sitting behind, and send it to another star at a pretty high velocity. That laser you could see from anywhere in the galaxy if you were just looking in the right direction. So it makes sense to look for these things. We've got an experiment cooking up that is going to do it, and other groups have too.
Now, one thing that really it really takes me in the last, especially a couple of years, maybe a little longer, but there seems to be a distance between science and the public. And you see that on all fronts, from climate change to aliens and UFOs are two of the main ones. How do we bring science to the public where they start understanding the basics better than they do now?
Yeah, well, this is actually not a new problem. It seems new because after the war, science, which was responsible in some measure for winning the war, I mean, think of things like the Manhattan Project, but also radar and many other things. These all came out of the laboratories of, physics and electronics departments at universities and so forth. This was all due to science. So scientists were suddenly, the golden-haired kids, and, they could do no wrong. They were given a higher ranking by the public in terms of credibility than almost any other profession. I remember when I was a kid, they'd have advertisements on the TV showing scientists telling you which brand of cigarettes to smoke because they would be the best ones for you. So science was great. But, people have become disillusioned. Now, why have they become disillusioned? Well, there are all sorts of things that can disillusion you about science because science is sometimes wrong. It takes a while to correct. It's self-correcting, and eventually it turns out to be right because you keep fixing it. That's unlike almost any other human activity, by the way. But, they would get some things wrong. And then there's always the phenomenon of trying to find some explanation for something that science has not yet been able to explain, like autism, right? We still don't quite know what causes autism. It's undoubtedly a genetic thing. But, it's much nicer to think, it's because I gave my kid some, vaccines when he was a baby. Well, right. That's been disproven over and over and over again, but the public still likes to believe it because it gives them some reason for the fact that their kid might be autistic. So as a result, they distrust the scientists, right? Climate change is another thing. It's very inconvenient for me to have to deal with this climate change, so I'm just going to disbelieve it. Well, you can disbelieve it, but that doesn't help you in dealing with it. And if you don't deal with it, the problem just gets worse. So, the scientists don't have a dog in that fight. They're just trying to figure out what's actually going on. And nonetheless, the public is inclined not to always believe them. I don't know what to do about it. The scientists are, obviously not the best at communicating what they're doing to the public. That's not their job. They don't know how to do it. And a lot of what you see on TV is just bonkers. So it's a difficult problem. But as I said, you had the same problem in 100 years ago, no doubt about it. And in America especially, much less so in Europe. In America especially, because America has always been somewhat distrustful of intellectuals. We're a frontier society, and those those gnarly, bald-headed, short guys in the white lab coats that you saw in the old movies, they were always causing trouble. Frankenstein, look at the trouble he caused. So anti-intellectualism is an endemic American trait.
I notice it big time when I'm in Canada as compared to the U.S., because in Canada, things like the climate change are just taken. It's just how it is. It is what it is type thing, and there's no question. But the thing is, what kind of gets me the most is people pick and choose what is science to them. So they're picking a lot of pseudoscience, kind of, make believe almost. They would choose that rather than choose something more academic.
Yeah, that's true. That's true. It's lamentable. It's not new, as I say. It isn't new, but it's also the case that science today is a lot more difficult than it used to be. I mean, if you wanted to be a scientist in 1850, or maybe the time of the American Civil War, you could probably spend a weekend at the library and become an expert on some aspect of science. Wasn't very hard, and you could do experiments, that would reveal something new. I mean, think about all those classic things, X-rays or penicillin or the discovery of new planets and things like that. That was all very easy to do back then because, the science was just kind of lying around waiting for somebody to pick up the easy parts, which they largely did.
Yeah,
today,
look at Tesla.
Well, yeah, he's not a scientist. I mean, he's an engineer. That's a different. Oh, you mean Nikolai? Sorry,
yes.
I thought you.
Yes.
Yeah, but he wasn't a scientist either, by the way. He never did anything theoretical. What he did was he was a brilliant engineer, so he could design all this electrical machinery. That's what Tesla did. If you look at the wall outlet in your house there, the fact that it's 60 hertz, 110 volt AC, that's largely due to Tesla. But, that's engineering. That's not so much the science. Neither he nor Edison were particularly interested in science. Nonetheless, it was a lot easier. Today, if you want to find the Higgs boson, you need a machine that costs $5 billion, and you got hundreds, if not thousands, of people working on the problem. Well, that's a little off-putting to Mr. and Mrs. Front Porch. Am I supposed to believe all these eggheads? It's discouraging to them, I think.
And that brings me to artificial intelligence. Where's it going? Is that something that we realistically can expect to happen?
Oh, I think you can very much expect it to happen. In fact, you can be seeing it happen. It's happening in many places. There are, I live here in Mountain View. I'm in the Silicon Valley here. And there's not a day I go by when I don't see at least, a couple, and often more than a couple, of self-driving cars here. They're mostly from Google, which happens to be down the street from where I am. And, you could say, well, that's sort of artificial intelligence, isn't it? It's just saying, well, we don't really need the driver part of this as an operation anymore. We can replace the driver. They can just become a passenger. And that's AI. I guess you could call that AI. I went to a talk recently by a fellow who came up from Southern California who was into artificial intelligence. He was a bit of an expert on it. And after his talk, which was kind of he pointed out a rather interesting example of what you can do. They took 16,000 microprocessors, ganged them all together, and just let it loose on the Internet to see if it could find anything on the Internet. And it did. It found cats, lots of cats. And it became very good at recognizing cats. And in the end, after, training on the Internet, it could recognize a cat in a photo or a video better than a human could. Well, you could say, so what good is that? Well, it's no good. But it does show you something that you can train these things to do things that humans can't do, right? Or diagnosing disease. Actually, the machines are already better at that than your doctor is. But, you like your doctor's bedside manner better than this big computer. But this fellow who came up to give the talk, he was asked at the end of his talk by somebody, so, what about my job? I mean, when is AI going to take over my job? And his response was, he said, well, if what you do is repetitive, which is like filling in tax forms or obviously any sort of factory work, if what you do is repetitive, you have 10 more years. So somebody in the audience said, well, what if what I do is not repetitive? It's creative. I write short stories, or I don't know, I direct movies or something like that. And he didn't answer that. He just smiled. I think that's the correct approach.
So I've got less than 10 years.
Well, I can tell you there are all sorts of, they can already write music. It isn't great music, but it's going to become great music. And I actually asked the head of the Stanford University Artificial Intelligence group a couple of years ago. I said, look, are we going to have a machine by 2050 that can write the great American novel? And he looked up at me and he said, yes. There you go.
So Seth, going back to SETI, what is the protocol? What happens if you get a signal that is definite? What do you do? Who do you report to? What is that process like?
Yeah, well, that's a question I frequently get. Many people among the public seems to think that it would all be covered up, right, that the government would swoop down. I'd like to see that. But, the men in black would show up and, it would all be kept from the public. And when they say that, I say, well, why? Why would you want to keep it secret? It's a big discovery, when Columbus lands in the New World. They didn't keep it secret. And he said, no, but the public couldn't handle the news. Well, I don't buy that. I can't imagine that if you opened up your browser tomorrow morning and read that scientists find a signal coming from 200 light years away, you would say, well, that's it. No more radio show, no more nothing. I'm just going to riot in the streets of Tacoma. You might say that, but I doubt you would say that. And there is a protocol. I was in charge of the committee that actually drafted the most recent versions of that. And all it says is, make sure that it's real. In other words, verify it. Secondly, tell everybody. And third, don't broadcast anything back without, consulting with somebody like the United Nations first to make sure that everybody's happy with that. That's all it says. But in reality, that's not what happens. In reality, what actually happens, and we know because of some false alarms, is that the media start calling up right away. That's what actually happens. If you get something that looks like a signal, there's no policy of secrecy, so everybody knows, and then, the newspapers and the local radio and TV stations start calling. That's what happens.
What was, several years ago, I do know of a false alarm, but what was that about? Were they actually, there was a bump or something that they actually heard?
Well, I'm not sure which false alarm you're talking about. There's the famous WOW signal from 1977.
That's the one.
Yeah, well, that's the most well-known. And because of the nomenclature, there were hundreds of other signals, but this one had a good name. So this is the triumph of marketing over product, maybe. But that was found at Ohio State University. They had a big radio telescope at that time in 1977, I think. And the guy who looked at the computer printout every day saw this big signal and he wrote "wow" next to it, so that gave it its name. It's never been found a second time. We've even tried many times looking for the WOW signal a second time, and so far nobody has found it a second time. And if you can't find it a second time, then you don't know what to say. If you hear chains rattling in your attic, and you go up into the attic to see if it's a ghost or something else, and you don't hear the chains rattling, and you just look around and it's just your attic, and every time you go up into the attic, you don't see anything that could produce rattling chains. What do you conclude about that first time that you heard it? You just don't know. And that's the situation with the WOW signal. Maybe it was ET and they just sent a short broadcast and then went on summer vacation or something. But on the other hand, maybe it was terrestrial interference. There are, really countless possibilities for what it could be. But if you can't study it, if you can't see it a second time, and by the way, this is very similar to the UFO reports. If you can't study it by seeing it more than once, then, you usually just have to throw up your hands and say, well, we don't know.
So how do you validate it? With what do you compare?
Oh, you'd immediately call up people at another radio observatory, somebody else who had equipment that could pick up the signal that you have found and say, you guys look for it, right? And you don't, maybe you give them the frequency or you give them the direction or something, and, you try not to bias them and just see if they can find it. If other organizations around the world can find it too, then you can feel fairly certain that it's for real.
So you mentioned something really cool, and before the show, me and Al were talking about Jodie Foster's famous movie Contact, but you knew this was coming. Come on, Seth. But let's say you get a signal, and you said something very interesting, not to broadcast anything back. Would you, or would you try, or what is that process like?
Well, I don't think we would broadcast anything back. We don't even have any transmitters, so there's a problem right there. But I think there would be people who would want to broadcast back, hey, we're the Earthlings, and, we've got some book clubs you may want to join or whatever. Plenty of used cars, you might want to buy something. I mean, there are going to be undoubtedly people who will, swing their backyard antennas in the direction from which the signal is coming and try and put a transmitter on it and say something. I don't know that would be terribly successful because you need a big antenna and a powerful transmitter. And so, some places could do it better than others. But, I'm sure that somebody's going to want to transmit back. And personally, I don't have any problem with that. If they want to do it, let them do it. But, the SETI Institute wouldn't be part of that because we have no ability to do that sort of thing.
Do you think it's wise?
Well, I don't think it's unwise. I mean, we've been broadcasting, relentlessly since the Second World War anyhow, right? And all those radars down at the airport, they're broadcasting 24/7 and, let them do it. I mean, you're not going to turn them off. I hope you're not going to turn them off. The weather's not always great at the local airport, so you want those radars working.
So if we get instructions to build a ship and send it out there to them, would you think we would do it?
Well, I don't think that would make a whole lot of sense. I mean, if they're 200 light years away, do you know how long it would take one of those ships to get there? I mean, I can tell you if you don't know, but it's on the order of 4 or 5 million years. So that's too long a rocket ride, particularly if you're in a middle seat. I don't think we would go out there, but you could conceivably send them messages. I mean, that goes at the speed of light. That's a lot faster.
Hey, it's okay. The movie Contact felt like it was 4 or 5 million years long, but
slow motion contact.
Yeah. What got you into this? Like, where was it starting for you?
Well, I was interested in this from 10 years old, I'm sure, because I was into, astronomy as a kid, and I went to all the sci-fi films and stuff, and a lot of them had aliens. Almost all of them had aliens. Well, not all of them. Sometimes it just had mutated monsters and things like that. But I was interested at a very early age. But later on, I studied astronomy and physics, and I worked for quite a while studying, researching galaxies and using radio telescopes to do that. So when the SETI Institute called me up one day and said, hey, you want a job here? I mean, it was stuff I sort of knew because I had used the same instrumentation for astronomy. And I, of course, was interested in aliens. Everybody's interested in aliens. So, they called at the right time, as it turned out, for me.
Yeah. So what are cluster galaxies?
Well, galaxies like to have buddies. I mean, the Andromeda galaxy is pretty near to ours. You can see it with your naked eye, actually, if you look in the winter sky at the right place. Just looks like a little bit of fuzz, but it's up there. So we're in a group of galaxies that include Andromeda and about a half dozen or a dozen other smaller galaxies. But there are some regions of the cosmos where you have many thousands of galaxies in essentially one small area of space. Now, small being a relative term here, and those are called galaxy clusters. The galaxies actually cluster together. That's what they are.
Wow. Now, have you ever dealt with people that believe we haven't been to the moon, and they have a couple of different reasons why, like the flag that moved and the shadows and stuff like that? Have you ever dealt with that scientifically and responded to that, or do you stay out of that?
No, I get calls every day from people who are having mostly difficulties with aliens. They call because they've seen something in the sky and they want to know what it is and so forth. So I deal with that on a daily basis. I don't know that I've ever had anybody tell me we didn't land on the moon because that's so easy to disprove. Maybe they're reluctant to call me up. I mean, that's less believable than saying that, there's a guy who lives at the North Pole who wears red suits all the time.
Well, there is.
Well, he's drifting. That's all I can tell you.
Yeah. Wow. So now, are you actually, you wrote a book about that. Are you actually searching yourself for aliens? Is that something you want to find?
Am I searching myself? Well, when I look down my shoes here, I don't see any aliens. Yeah, obviously, I'm part of the SETI project here at the SETI Institute. Yes, that's what I was hired for.
And so you're actually, do you believe you're actually going to find one?
Well, I bet everybody about 6 or 7 years ago, I don't remember exactly, everybody in an audience that I was speaking to, this was in Europe, but I bet everybody a cup of Starbucks we'd find something within 24 years. So either going to have to buy a lot of coffee or we'll find something. So there you go. That's my take on it, and that has to do with the improvements in technology used for the search. Because it's mostly digital electronics, it's mostly computers, and the speed and the abilities, if you will, of computers increase very, very quickly. This is known as Moore's law, but never mind what it's called. It's just that if you take that into consideration and say, well, how many star systems could we check out for signals in the next 24 years? It comes out to, millions, and millions might be the right number to actually find something.
Now, about 10 years ago, they had this program that they had announced on Coast to Coast that you could leave your computer up and online, and SETI would actually use the power of your computer and combine them all together. Was that actually a thing?
Well, it still is a thing. It's called SETI at Home.
Yes.
And it's a project of the University of California at Berkeley to process some of their SETI data. They collect SETI data, too. They're the other major SETI enterprise in the world today. And so some small percentage of their data are actually farmed out to these millions of people who've downloaded this software for them to process. And, of course, it automatically sends the results back to Berkeley. So this gives people with home computers the ability to participate in the search, because when they, leave their keyboard idle for a couple of minutes when they go to the kitchen to get something to eat, then their computers can process a little bit of data. It's the biggest computer in the world by some measure, so it's a very successful program.
Wow. So would that increase the chances of finding something, or is it just like beefing up what you already have existing?
Well, as I say, this is not run by us. It's run by the University of California at Berkeley. Yeah, of course it increases the chances. I mean, any additional processing you can do increases the chances. It's sort of like saying, I think there's, my car has been stolen, so I'm going to search the blocks around where it last was and see if I can find it. But if you can increase the extent of the search, of course, that increases the chances that you may find your car.
So what kind of upgrades has SETI done since its inception?
Oh, well, it's considerably different. I mean, it's reckoned that today's SETI experiments are about 100 trillion times faster than the experiments the first experiment that was done in 1960. And that's mostly due, again, to computer technology, the fact that you can scrutinize the radio dial more quickly than could ever have been done in the past. So it's technology that's improved, but not only, it's also the astronomy. Back in 1960, we didn't know if there were other planets out there beyond the 8 or 9 in our solar system. We just didn't know. We thought that there probably were, but we didn't really know that. But today we do know that. I mean, we found thousands of planets, and we realize that almost every star has some planets. I mean, planets are very, very common. That means there are like 1 trillion planets in the Milky Way galaxy. And, of course, there are a couple of trillion other galaxies, each with 1 trillion planets. Those are all things that encourage the search because, again, there's so much real estate available that it's hard to believe it's all empty.
Who are your biggest influences? Like, who kind of helps shape you?
Help shape me? I suppose my teachers, more than anything.
Oh, yeah. No, but no science fiction or any other.
Well, I certainly liked the movies. I would go to the movies every weekend. I didn't, there were plenty of sci-fi and continue to be plenty of sci-fi films. So I think that those were influential. I actually consult for films now, and I think I do that because of the fact that they were so influential for me. But there was no one particular person, and I didn't read much science fiction. I didn't find that so interesting. I read a little bit of Isaac Asimov, but I didn't in general read science fiction. No.
So now with the space thing, like going into Mars and stuff like that, and talking about resettling it or making it a settlement there, do you believe that'll ever happen?
Oh yeah, for sure. I'm sure we'll do that. I mean, we'll get humans off planet Earth and actually living somewhere else. Certainly in this century. And you could say maybe the International Space Station is kind of a bit in that direction. I mean, people go up there for months and they just live there. I mean, that's not on Earth. But I'm sure that by the end of this century, you'll have people living in rotating aluminum cans in orbit around the Earth, space colonies on the Moon, on Mars. You can do that. Both of those are very tough environments. But on the other hand, you can just build some sort of structures and live on the Moon or Mars. Putting people into orbit near the Earth is a better deal for them because they don't have to go as far. They can come back for visits and whatever. They can even pick up TV and stuff like that. So, I figured that the big operation will be getting people living in orbit. But certainly we will colonize whatever nearby real estate we can that's in the least way suitable. That doesn't extend to planets like Venus or Jupiter or Saturn or any of those. Those are very much different environments.
Now, you bring up a good point, Seth. Why don't we move this outside of Earth's orbit so that we're not fighting against our own atmosphere to listen or to send? Why don't we move this program to, for example, the International Space Station or put it on the Moon, where we're at least outside?
Well, of course, the atmosphere really doesn't interfere with radio signals, so that's not such a big deal. But the simple answer is money. I mean, you got the money to put giant telescopes in the International Space Station or on the Moon or on the Mars. I mean, we barely have any money to run them here on Earth. So it's mostly money.
Oh, man. It always comes down to that, because I think it would help us incredibly.
Well, yes and no. I mean, as I say, radio, you can receive it just as well right here on Earth as you could in 200 miles up at the orbit of the space station. That makes absolutely no difference. It's like saying, oh, yeah, I'm going to check out what's going on in downtown London today, and you take, 20 steps in the direction of England and say, now it's much better, huh? Well, no, not really any better, but...
Touche, Seth. Touche.
Do we have any real... Is there such a thing as any real way of making us so that we can be put asleep for a certain amount of time and travel far away and awake, kind of like how they do it in the movies?
Well, we can certainly put people to sleep. The question is whether you can wake them up.
Yeah.
Nobody has been able to demonstrate. I mean, suspended animation. To me, that just means that a Bugs Bunny cartoon got stopped somehow in the middle. But suspended animation, which is what you're talking about, and happens all the time in the movies, you put them in what looks like a high-tech coffin, and then some machine wakes them up as they get close to their destination. We don't know how to do that. I mean, it isn't to say that you might not be able to do it. You can certainly lower the temperature, and then they'll, stay asleep in reasonably good condition for a while. But a while might be months. And, if you're going to go to the nearest star at the speed of our rockets, it takes 75,000 years. So, it's got to be something better than that. So I never say never. I mean, of course, maybe it's possible to do this. We simply don't know how to do it now.
Yeah, and they better have Starbucks on board if they're going to be that long.
But it'll be freeze-dried.
Yeah, I couldn't take it. I couldn't take it.
You put me to sleep for a couple 100 years. I don't want to wake up. That's the best sleep I've gotten in a long time.
Yeah, well, that's maybe true.
Now, the space station. What's the big purpose of the space station? What are they doing?
Yeah, what are they doing? I mean, you can look up what they're doing on every day, but they're mostly doing experiments that are of the type that would, either help us here on Earth, new manufacturing techniques. If you can build things in zero gravity, can you develop new techniques that might allow you to build something you can't build on the Earth? And that's certainly possible. If you're talking about very small things, for example, gravity could get in the way. So there's that. Also, though, a lot of it is human factors research. If we're going to send somebody to Mars, you can get somebody to the space station in a rocket ride of minutes. Right? It doesn't take very long to get to the space station. But to get to Mars takes 7 months. And so anybody who's going to Mars is going to be exposed to a lot of radiation and stuff like that. And in the space station, you can study these sorts of things in a way you can't do on Earth. So some of it is just directed toward the next steps in space exploration, I guess you could say. But, it's also, can you learn anything about the biology of critters here on Earth? Usually small ones, microbes and things like that. Just trying to tease out some information that you're not going to get on Earth because of the conditions being so much different in space. So it's mostly research, human factors for astronauts, and just basic science research.
Is there any possible way that aliens could be around us right now and we just can't see them?
Well, if you can't see them, if you can't measure them, can't detect them, then it's not a very interesting question, is it? I mean, yeah. It's like my saying, hey, I'm sitting here in this room, but there could be a big party going on in the 10th, 11th, and 12th dimensions, and I just don't know it. Well, maybe there is. But so what? I mean, if I can't prove it, right, then it's just sort of an idea, but it doesn't have any basis in anything you could prove and show to be true. It's just like saying, I think that there are fairies hovering over this part of California, 500 miles up. But if I can't think of an experiment to show that that's true, then nobody's going to listen to you very long. Yeah.
Well, Seth, it's been a great conversation. Our guest today from the SETI Institute has been Seth Shostak, senior astronomer and author. Thank you very much for being on the show.
My pleasure.
To find out more about our show, guests, or to listen to past shows from our archive, please go to www.houseofmysteryradio.com.
Show's over for now.
Was it as good for you as it was for me?
Well, good night.
This has been a production of Something Weird Media.
I'll be back.